The question is, Savita and Hamida are friends. What is the probability that both will have different birthdays and same birthdays? That's the second part. And it is given in bracket, ignoring a leap year. And a leap year consists of 366 days. So we are avoiding that. We are taking only a normal year which contains 365 days. The question is, we have to find, first part of the question is, we have to find the probability that they will celebrate different birthdays. For example, suppose Savita's birthday falls in the month of January and let it be on January 25. So actually the question is to find the probability that Hamida will be celebrating her birthday other than January 25. Is it clear? The question is to find the probability that both will have different birthdays. Okay. So suppose Savita is celebrating her birthday on January 25. So our question is, we have to find the probability that Hamida will be celebrating her birthday other than January 25. So altogether in a normal year there are 365 days. So one January 25 must be avoided because we have to find the birthday of Hamida is on some other days, isn't it? That means what is the number of favorable outcomes for Hamida's birthday? It is 364. Isn't it? Divided by total number of outcomes is 365, which is the number of days. Clear? I will say another example. Suppose Hamida is celebrating her birthday on March 3. So our question is, first part of our question is, we have to find the probability that Savita celebrates her birthday any other day other than March 3. So there are altogether 365 days. So one day, March 3rd is already birthday for Hamida. So Savita has to celebrate other than this March 3. That means favorable outcomes for Savita is altogether there are 365 days minus this March 3rd. That means one day. That is 365 minus 1, which is 364. That is the number of favorable days favorable for Savita's birthday. So the probability will be, required probability for the first part will be 364 is the favorable number of days, and what about the total number of days? It is 365. Okay. In the second part, what's the question? We have to find the probability that they have the same birthday. So if I am dealing with the first case, suppose Savita is having her birthday on January 25. Second part of the question, we have to deal with the probability that they have the same birthday. So if Savita's birthday falls on January 25, surely Hamida's birthday must also be on January 25. That means how many possible favorable outcomes are there for Hamida? Her birthday must also be on January 25. So how many possible days? 1 by what is the total number of days possible? 365. For the next example, suppose Hamida is celebrating her birthday on March 3rd. In the second part, we have to find the probability that they are celebrating it on the same day, isn't it? So Savita's birthday also must be on March 3rd. So if they both have to celebrate it on March 3rd, the number of favorable days will be 1 divided by total number of days is 365. So for the second part, required probability will be equal to 1 divided by 365. Only on one day they both can celebrate the same day as their birthday, and 365 is the total number of days.